Hello everyone. In this session, we are going to demonstrate inter-process communication using shared data structure. And to make it more interesting, we'll create two processes using fork inside a single program, a single C program. Here is what we will be doing. So parent process would be there, which writes the data, and child process would be there, which reads and performs the operations. Both will access the shared data structure, same shared data structure. Let's write the complete program step by step. And I would be discussing about while I'm typing, I'll be discussing what exactly we are going to do. So let me write G Emacs. So shared data structure dot C. So as usual, when we do talk about shared memory or shared data structure and even IPC, we have to include few specific files. Okay, so let me traditional files. Let me add them as headers or header files. Hash include, and then unistd dot h. Then we have to make use of internally, because we want to implement SPC, hash include sys slash IPC dot h, then hash include sys slash shm dot h. Okay, then hash include sys slash types dot h. These would be necessary. Correct. Now let us create the data structure. I will explain the whole program. Struct data. So I'll be taking integer first, comma second. Fine. These would be the variables from our data structure, and I'm going to make use of a flag already. Okay. I will explain why I'm using this one, because I'm writing, I'm reading and writing. So I want one flag which will communicate the other process that data is ready. You can make use of it. Correct. So let me do this. So let me write integer main, then curly bracket. Let us create key, because this would be required for shared memory access. So let us say this, I'm adding this as key as 1, 2, 3, 4. Now let me create the shared memory. So how do I create it? So integer shm id equal to shm get is the standard function which I would be using. I will write key, then size of, then our structure is to be used. Struct, then our variable data, comma, then the flag IPC creat pipe 0666. So we created a shared memory now. Now we have to attach this shared memory to with the data structure. So struct data, let us write data. This is a variable that I am creating. So struct data star, now attach shm80, then shm id, the one which we created, shared memory id. Then we don't want to specify any other things other than that, and then later this. Okay. Now our status, let us communicate to the system by initializing this ready pointer, ready flag for a while, not a pointer, ready flag for a while, because we created data as a variable. So I am writing this as 0. Fine. Now let us create process. PID is equal to fork. Now we know that if fork is greater than 0, that means it is a parent process. So what we want is parent process, we want to work or act as a writer, and the child process would be reader. Correct. So we'll write, child process will read it and will operate onto that. Okay, like say it will be adding both variables values, subtract and multiply it together. Okay, so we are working with these two, first and second thing rather. Correct. Now let us write the parent process code. So if PID greater than 0, this would be our parent code, parent process code. Fine. So let us printf and say parent process enter two numbers scanf. Now we have to read those values. %d, %d, ampersand, data first, comma, ampersand, data second. Correct. So we declared those both variables as a part of data structure. Now data pointer ready. Like once it is reading the values, so we are going to modify that flag, which initially we said 0. So we are setting it so that we can signal the child, boss, I have added the data. Now you work upon this. Now once it's done, we will write by writing the message to the parent child in the parent process, data return to shared memory. Correct? /n. Fine. So this is what our parent code is. Now let us write in the child. Else if PID equal to 0. So this would be definitely a child process code. So we have to wait until parent writes the data. Correct. We don't know. Like we know through the scheduler, what we understood was like scheduler can schedule say child process prior to uh, parent process as well. Ready is not equal to 1. Until it is not 1, wait. Once it finds, then printf child process reading the data /n. Now what we'll do is once it reads the data, we'll write up, we will do the operations. Addition colon %d. Now what would be added? So data pointer first plus data pointer second. Semicolon. Similarly, we'll write control Y, control Y. So this would be subtraction, this would be multiplication. Because we are considering a data structure parameters first and second, that's why we are going to make use of this. Subtraction and then multiplication. Correct. So this is done. Now, once it is done with this, so we have to detach the shared memory from both the processes. And then like once detach is done, we have to write into process if PID is greater than 0. Okay, then what is to be done? We have to delete. So SHMCTL deletes the shared memory. SHMID, comma, IPC, RMID. Remove that ID and then null. correct? Curly bracket complete, and just write return 0. Done. So let us save this code, and hopefully there are no errors. If there are errors, then we'll work out. GCC shared ds dash 32 dash 132. Let us see. Okay. I think I wrote wrong. I should write 0 there instead of O. Done. Okay, let us execute this. So if we see on another terminal, ps dash ej capital H, you should see a dot out and a dot out. Parent and childs are running. So let me write 4. We will give say 4 and 19. Now you can see parent data returned to shared memory, child process reading the data, addition is 23, subtraction is minus 15, and multiplication is 76. So let us go back to the code and we'll format it properly. So we'll write here /n /n /n, correct? And then with the last also we'll write /n. So once this is done, we'll write printf child process the data by reading, correct? So this would be again /n. Save it. Now let us execute it one more time. So let us give 25 and second number 7. So addition is 32, subtraction is 18, and done. So if I see here, if I execute, if I see one more time, I can see 2 things are done. So I am giving 4. I can see still it is there 8. So we can add there like a sleep if required. So let us do that so that one can see like what is happening. Sleep 10 and whoever is getting chance to execute can be seen. GCC execute. Okay. Now first number 25 and 6. Now let us see whichever process finishes. You can check it out here. Once their 10 is done, 10 seconds are done. Both of them are gone. So ultimately the work has been done. Now if you see, let me cut down this code and let me explain that line by line one more time. So we have declared a structure here. It is a shared data structure. I have declared as elements as first and second. These are input values, and we have taken ready as a flag to coordinate parent and child. This structure is what both processes will share. Then we created the key. Correct. This key uniquely identifies the shared memory segment. Then we have written this SHM ID. We created this SHM ID. So here key is identifier. Correct. Then size of struct data. That means we have to declare get memory size. Then 0666. This is permission. IPC create if it does not exist. And this statement creates the shared memory block. Now we have to attach that with our data structure. So shared data, then we are attaching it with SHMAT. This attaches the shared memory to our processes. Now data behaves like a normal pointer, but it actually points to the shared memory. Then what we did was we initially assumed that no data is written. So that's why we set the flag to 0. Correct here. Further, we created a process. like a new process. Parent would be getting, as we know, through the fork, parent gets child PID and child gets 0. Now both processes execute the same code. Then we are writing if PID is greater than 0. That means this condition would be true always for if it is a parent process. Then we are reading, we are reading two values for the both the variables, first and second. Parent writes these values into the shared memory because we assigned it through the scanf. So once we wrote it, we have to communicate to the child that I have written. So this particular statement, data and ready like equal to 1, this signals child that data is ready. Now if it is a like say then we added sleep 10 to see like what is happening there, and this block like then we have else if, and this block is executed by the child by writing PID equal to 0. We are checking it. So we are saying like if child gets a chance to execute while data ready parameter is not 1, keep waiting, continuously check until parent writes the data. And this is a simple coordination mechanism. Please understand that. Then once we get that data, we are adding them. So data A first and second is added and written directly reading from the shared memory. And then similarly for subtraction, multiplication, so on. Then once done, like again we have written sleep 10, then we have to detach the shared memory from the processes. Correct. So we wrote SHM DT for detaching purposes. And then we have to remove the shared memory completely from the system. So that's why we wrote in parent SHM CTL. Now let us consider the key insights here. Parent and childs are separate processes, the way that we saw on other terminal by writing PS-CJH. And that is the like power of shared memory. But let us understand when those two separate processes are created, they are accessing the same structure in the memory. And that's what I said, like it is power of shared memory. And this example clearly shows how processes can communicate using shared data structure efficiently. Now, you can keep modifying this code by adding, say, division parameter there. Okay, you can add more fields, use array in a structure. So, like when we say fork, this is very important moment. Now, while we are checking in the child, like it is waiting till 1 is there, it keeps checking. So what we can do is what we understood here is like if at all we have to work with two processors with shared memory, how exactly one can do this. Thank you.